Hello everyone. This is an example that we're going to solve in this video that is dealing with turning sources off. So in this example, I will give you a schematic. So here's the schematic here. This schematic, the circuit has two different sources. There is a 100-volt source to the left. There is a 25-volt source to the right. And there are three different devices, 25 watts, two of them, and a 50-watt load as well. What we would really like to do here is find the value of this current I1 if my 25-volt voltage source is turned off. So you may have this in a real-life situation, so let me make it slightly more practical. You basically have three devices that you are powering through two different sources, and somebody asks a what-if scenario. What-if scenario could be, what if my 25-voltage source is being turned off? Maybe I have a power failure. What would be I1? If indeed my 25-voltage source fails and is removed from that circuit, would I1 be so high as to perhaps burn the wire here? Am I still within safe limit? It's a fair question to ask because, as you can imagine, those three devices here, this 25 watt, this 25 watt, and this 50 watt, are each going to still draw the power that they need. And so that means you still have to provide 100 watts to that circuit, but now the left source will carry all the burden. So naturally, its current will have to be increased since now it's providing all the power itself. And so the question is that safe? Would I1 be low enough? So as we have learned, turning the 25 voltage source off basically means replacing it with a short. So if I replace this voltage source with a short, I will get the circuit that you see right here. Here is where the voltage source used to exist. Now I have a short circuit, and now I can basically solve my circuit. So I can find, for example, here that the 100 volts that I'm supplying from the power supply times I1, which is the current, must be equal to all the power that is being consumed on that circuit. In other words, I'm applying the principle of conservation of power. The total amount of power supplied by the source, which is 100 volts times I1, notice that this is written as it should be in the active sign convention, must be equal to 25 plus 25 plus 50. Which of course this means that my current I1 will basically be equal to 1 amp. So now you can answer the question that I mentioned in the beginning, is this too high? Well, in what you would have to do in real life is you would have to find out if all of the wires that you will have that will have to support the current I1 can actually handle 1 amp. If they could, fine, there will be no problem. You have now done the safety analysis, the what-if scenario that I discussed in the beginning. Now, I really do invite you to go back and exactly do the same problem. I'm going to remove that short here, but now ask exactly the same question and solve your circuit with a what-if scenario for the 100-volt source. So what if the 100-volt source is removed? What if this guy here becomes a short circuit? How much would I2 be? Well, it will turn out, and I hope you can actually do it at home, that I2 would be 4 amps. And by essentially turning off V1, you should be able to solve this fairly quickly and find the I2 to be 4 amps. So thank you for watching this video. I hope this was a good example for you to reinforce your understanding of how to turn sources off. This example, I did the voltage source, but you can quite easily, in exactly the same way, turn off a current source, in which case, of course, you would replace it with an open. Thank you. See you next time.